Okay, we're going to pick up right where we left off with solving compound inequalities. Again, separate the inequality into two separate problems, isolate the variables, write the final answer using the word and or its shortcut or the word or, then graph the solution. Remember, and graphs are no arrows, and because they meet, and or graphs, arrows in both directions. So let's solve one. What are the solutions to -2 is less than 3y minus 4, which is less than 14. I'm going to split it into 2. So -2 is less than 3y minus 4. And then I'm going to go and I'm going to take through this 3y minus 4 is less than 14. So I split it into 2. So I'm going to solve my equation and isolate the variable. Here I want to add 4 to both sides. -2 plus 4 is 2, is less than 3y. Then I'm going to divide both sides by 3. That gets rid of my coefficient, so y is greater than 2/3. I will keep it as a fraction. Okay, over here, add 4 to both sides. So 3y is left, and then I have 18, divide both sides by 3. So that gets rid of that. Y is less than 6. So then I would write this, if I were to graph it, I would have 2/3 and 6, and I'm kind of doing this kind of quickly, where 0 would be here. Now y is greater than 2/3, so it's going to be, it's not going to I knew that was going to start working sometime. Sorry about that. Anyway, so 2/3 is not going to be, and it's going to be 2/3 is less than y, or y is greater than 2/3. So it's going to be anything this way. I should highlight it so I know, it's going to be anything this way, and then the next one I highlight is going to be the other way. So 6 is going to go here, an open circle, and its y is less than 6, so it's going to go this way, and so wherever those two meet is going to actually be your shaded area. You would want to erase any of this. So your final answer is going to be the two between here, and it's just going to be shaded in between. I'm not actually going to keep like this part shaded. I can rewrite this in the shortcut form, which is writing the 2/3 is less than y, which is less than 6. So I could write it like that also. If I go back up to this, my first step with where it was separating the two, I did in both problems first, I added 4 on to both of them. And then the next thing I did was I divided by 3. So if I wanted to, I could actually do this without separating them completely. Let me erase some of my work real quick. And what I'm going to show you is you can, if you have this compound inequality, whatever I do to the inside, I have to do to either side, both this side and this side. So I can add 4, and then I would have to add 4 to both of these sides. And here I would get 2 is less than 3y, which is less than 18, and then I would have to divide by 3 to isolate the variable. And this would just be a shortcut way to do it. Until you're comfortable, I would keep separating them into 2. This would cancel out, y equals 6. Okay, this one is an example of an OR. Again, this one you're going to keep separate, -2y plus 7 is less than 1. I'm just going to rewrite mine. Less than or equal to negative 5. So this one I want to subtract 7 first. Negative 2y. I would get negative 6. Divide by a negative 2. Divide by a negative 2. I get y is less than 3. One thing I always forget is I need to I'm dividing by a negative, so I need to change the direction of my sign. So it would go this way. Okay, here I'm going to subtract 3 first. So 4y is less than or equal to negative 8. Divide both sides by 4. So I get y is less than or equal to negative 2. Here I have a lot of students that say, well, I'm dividing, this one's negative. Nope, it's the number that you are dividing by. And then I'm going to have, I'm not going to write it as it's going to be y is greater than 3 or y is less than negative 2. So if I were to graph these, I know that this is an or. Gotta love the highlighters. This is an or. So I'm going to go put on here the negative 2 on my number line. And again, I'm doing the number line really quickly. You should actually, make it a little nicer. Y is greater than, remember, it's opening up towards the y, so it's greater than 3. It does not include 3, but it's greater than 3. So it's going to be everything up here. And y is less than, so it's anything to the left of negative 2. It doesn't include 2, negative 2? Yes, it does. So this would be the closed one, and this is going to be my shaded side. So again, that's where the OR graphs, arrows are going to be in both directions. The AND graphs, there's no arrows. They meet. Oh, I erased it, my graph, didn't I? But this one, arrows in both directions are highlighted or shaded. Okay, this one, this is my AND. This is where I'm not going to separate them into two. I'm just going to show, that quicker step right away where I'm just going to do it to either side. So I'm going to, or both, this side and this side. So add 4, it cancels out. Negative 3 plus 4 will get me a 1. M is left, and then 3. So here, M, now I'm going to think M, if I want to start with this one, is going to be less than 3. I'm going to put both my numbers down. M is less than 3, but it does not equal 3, and it's going to go this way. And then 1 is less than M. So that means this has got to be less than the shaded part. I could also read this part as M is greater than or equal to 1. So it's equal to, so it's going to be shaded, and it's going this way. So it's where they meet in here. Okay, get this little guy out of here. Alright, we got an OR, so we're going to do 2 separate ones, add 1, we get 2n is less than negative 2, divide by 2, divide by 2, we have n is less than a negative 1. So if I wanted to, I could graph that right away, I could solve them both, and I might solve them just because it might change the way my graph looks. So I'm going to subtract 2, I get negative 3n is less than a negative 6, divide by negative 3, n is greater than 2. So I have a negative 1, and put that back up there, and a 2, Both of them, right? I'm not missing one. Yeah, both of them are going to be open circles. So n is less than -1. Anything less than is going to be to the left. N is greater than 2. Anything to the right is going to be 2, greater than, sorry. So think about this. 3 would be in here, right? If I put 3 in for n, 3 is greater than 2, right? Correct. It's just saying that any number that's greater than 2 and that any number that is less than -1. So any number could satisfy this one or this one. All right, so we have a word problem, always fun. To earn a B in your algebra class, you must achieve an unrounded test average between 84 and 86 inclusive. So that means it's going to be included. You scored, 1 second. Okay. Anyway, so it's going to include 84 and 86. You scored 78, 78, 79 on the first 3 out of 4 tests. Is it possible for you to earn a B in this course? So assume that 100 is the maximum grade you can earn on the test. Can you get a B? Well, first, what do we know? We know that their average, the test average, must be between 84 and 86. So I'm guessing my 84 and 86. I want them to be between that. Well, for the whole class. So I'm thinking that it might look something like this. My test scores have to score, I need to score between there. I do know my first 3 test scores that are 78, 78, and 79. They're also an average. So how do you find the average? Well, you add up the test scores and you are going to divide by however many test scores. Well, there's 4 test scores. So you're given the 78, or they'd say they got a 78, 78, and a 79. But we don't know that third or fourth one yet. So you would do all right. Now, how do I find the average? I add them all up and then I divide by 4. So what I'm going to do is I'm going to add these all up. Pause, I gotta. All right, so we got, there we go. I added 78 plus 78 plus 79. I got 235 plus x, all divided by 4, less than 86. Oh, less than or equal to and greater than equal to 84. Okay, now I need to solve for my x. Remember, order of operations tells me that normally I would do 235 plus the x and then divide by the 4. So now to undo that, I have to get rid of the whole thing is being divided by 4. So I'm going to multiply this whole thing by 4, and that will get rid of my 4 on the bottom. But whatever I do in here, I would want to multiply on the outsides also. So 84 times 4 is going to be 336. And then 86 times 4 is going to be 344. So now all I have left is this top, 235 plus x. So this is what x, or my last test score, should have to be so that I will score between an 84 and an 86. Okay, so I would subtract, I'm running out of room, I would subtract 235 from both sides, and I would get, okay, I worked the problem out, and I have to subtract 235 from both sides, and you see that x would have to be between 101